Welcome back, welcome back, welcome back to Algebra 1, Chapter 8, Section 6 in this book. Now the board might look very familiar because I didn't actually even rewrite all of it. Where it said exponential growth, I erased and put decay. Where it had a plus sign, I erased and put a minus sign. Here, and there, and there, and there. Because growth is the same as decay, but a minus sign. So let's look at a problem. Remember that C is your principal, what you start with. R is the rate, written as a decimal. And T is your time. And you fill it into the formula. And I want you to write the formula every time. Now, if it is an exponential decay, you start with a lot and it gets less. And it goes more and more towards your asymptote. Now, with this, you actually could get down to nothing. But where with a growth, you started with something, so you won't actually get down to nothing because you started with something. Hopefully that makes a little bit of sense. All right, so say we got money. And one thing that happens to money is inflation, where it's not worth as much. If you had a certain amount of money in the 1910s, I think you could buy a house for $3,000. I could go buy a house and pay for it. But now houses are way, way, way more than that. So governments kind of cause inflation sometimes. It's a way that they sort of steal from their people sometimes by printing too much money. I remember when I was a kid, Mexico was having a problem with this. And there was a picture of a lady who had a wheelbarrow full of money, a wheelbarrow full to go buy groceries for her family. Where, that's just a crazy amount. And my husband went there once on a mission trip, and he said there were all these tiny little coins that were just all over on the ground. And he was like, doesn't somebody want to pick these up, and spend them? And they said they're worth nothing because of inflation. And I'm like, but if you picked up enough of them, wouldn't they be worth something? But they said no. So inflation happens in our country too, not just Mexico. And so like what the dollar used to be worth was $1, but then we've had about 3.5% inflation for 15 years. How much is the money worth now? Well, $1 is our principal. We put it into our formula, 1 minus the rate, so you go over 2 times to turn it into a decimal, 0.035. In parentheses, raise it to your time, 15, and that dollar that was worth $1 will only now buy 59 cents worth of stuff. So watch out for inflation. All right, and then inflation also is controlled by the Fed. It's controlled by politics. So there's more to it than what I said. You can do a whole degree in money stuff. All right, what about a car? This one I understand better. I don't know that much about banking. I know more about cars. You buy a car for $18,000. It depreciates, it gets worth less every year at a rate of 12%, which change that to 0.12. After 8 years, how much is your car going to be worth? Well, we put it into our formula, 18, 1 minus 0.2. And remember, if we did this out, it's always going to be less than 1. To 8 years, it's going to be worth, put it in your calculator exactly like that, $6,473. I can't afford that, and I am in the market for a car. I can't afford that. So I need to find one that started off that and is 8 years old, and maybe I can buy that one. I had a Volkswagen Beetle, and I sold it because it kept breaking, and I gave it to this guy, and he fixed it for like $20, and he's driving it everywhere, and I was like, oh, maybe I should have got it fixed. All right, here's another one. Aspirin breaks down in your blood at a rate of 20%. So if you started with 500 milligrams of aspirin in your blood, how much would be left after 3.5 hours? So you start with 500 milligrams, you change that into a decimal, 1 minus 0.2, 3.5 hours, you'd have 2.29 milligrams. That's why they have the arthritis aspirin that's slow release. It keeps the level up higher so you don't start hurting more and more as you go along. So you need to be able to realize, is this an exponential growth or decay? You started with a lot, it went down, that's a decay. And if you looked at this part, it would be a minus or it would be less than 1. Okay, this is a growth. You start with a little bit, you ended with a lot. So this is a growth. it would have a plus in the formula, and x would be greater than 1. This together, that part of the formula ends up being greater than 1. What if it's a straight line? Then it's linear. It's a linear equation, not an exponential equation. Alright, so that's it. I think this is real easy. We'll do harder, more fun ones when you get to Algebra 2, but this is a great introduction. That's it for Chapter 8, so be sure to do all your homework, practice it. Do a problem, check the answer in the back of the book. Do a problem, check the answer in the back of the book. There'll be calculator labs that go with this, so make sure you go back and watch those too. It'll be a little bit easier to understand what's going on in the calculator. And come back and we'll do Chapter 9. Math is great.